Okay, this is lesson 4.4b. In this lesson, we're going to take another shot at graphing quadratics in this form. And last video, we discussed that this form is called vertex form. And the reason it's called vertex form is because the h and the k give you the vertex. So we're going to use that to our advantage. And to do this, I wanted to show you a second way to graph, and it's called the step pattern. And the reason it's called the step pattern is because every parabola we know is symmetrical, and it's symmetrical because it follows certain steps on both sides of the vertex. So let's look at the original parabola, the basic quadratic relation y equals x squared. If we were to come up with a table, the table we've actually been using just has these values. -2 is 4. -1 is 1, 0 is 0, 1 is 1, and 2 is 4. And that's because those numbers on the left, if you square them, you get the numbers on the right, and that's what the equation says. Take the x's and square them. If we do that, we end up with this nice parabola. I've added 2 more points. -3 squared is 9, and 3 squared is 9, to kind of make the parabola a little bit bigger, and to get us our step pattern. Now, in a previous lesson, we discussed the idea of a first difference. And the first difference is the change in the y's. So we're going to look at the first differences. Now we know, since it's a parabola, that they won't be the same number, but if we do a little bit of math, 9 to 4 is down 5, 4 to 1 is down 3, 1 to 0 is down 1, 0 to 1 is up 1, 1 to 4 is up 3, and 4 to 9 is up 5. If you take a look at the numbers 1, 3, 5 and 1, 3, 5. If you look around the vertex 0, 0, the steps 1, 3, 5 are on both sides, and that's called the step pattern. So let's take a look really quickly. The vertex of our original parabola is 0, 0. Our parabola opens up. And if you start at the vertex, this point right here, if you want to get to the next point on the graph, you would go over 1, up 1, and you would get this point. That's 1. If you want to get to the next point on the parabola, you would go over 1 and up 1, 2, 3. 3. If you want the next point, you would go over 1, up 1, 2, 3, 4, 5. And if you look, those numbers are those first differences. 1, 3, 5. So those are called the step pattern. Over 1, up 1, over 1, up 3, and over 1, up 5. 1, 3, 5. In fact, if you do that on both sides, you get the same steps. Over 1 to the left, up 1, that's another 1. Over 1, up 3, there's your 3, and over 1, up 5, there's your 5. Same steps, 1, 3, 5. So using those steps, we can graph a parabola, if you remember 1, 3, 5. And the reason we can do this is because, well, the vertex is in the equation, and we can use the step pattern. Now there's one hitch to this. The step pattern is not always 1, 3, 5. In fact, let's look at another relationship. Y equals 2 times x minus 3 squared plus 2. This is not the original parabola. But if we create a table of values, we can get some points that we can use to come up with a graph. So I'm going to complete a table here. If I take -1 and put it into the equation and square it, we get 34. If I put 0 in, I get 20. If I put 1 in, I get 10. If I put 2 in, I get 4. If I put 3 in, 3 minus 3 is 0, squared is 0, times 2 is 0, plus 2 is 2. If I put 4 in, 4 minus 3 is 1, 1 squared is 1, 1 times 2 is 2, 2 plus 2 is 4. And then if you notice 4 and 4, that implies that our next point's going to be 10. And if I keep going, say 6, the next point's going to be 20. Let's look at the first differences and see if the step pattern's in there. The step pattern was 1, 3, 5. Well, this is down 14. This is down 10. This is down 6. This is down 2. This is up 2. This is up 6. This is up 10. So our vertex is here, 3, 2. And if we remember by looking, H and K, there's your vertex. Our vertex is 3, 2. I'm going to graph that, 3, 2. And I could graph the rest of these points and we'd have a parabola. But the idea is we don't want to have to make a table. We want to be able to graph the vertex and then use the steps. But these steps don't look like 1, 3, 5. From the vertex, if we go down, they're 2, 6, 10. And if we go up, it's 2, 6, 10. Our steps are 2, 6, 10. What's weird is the steps of the original parabola were 1, 3, 5. So what's going on here? Something's happened to our steps 1, 3, 5, and it's turned them into 2, 6, 10. If you think about it for a second, you might see what's happened. Something's happened to 1, 3, 5 to make it 2, 6, 10. And what's happened is all those original steps have been multiplied by the number 2. The question is, why have they been multiplied by 2? And if you think, you might be able to figure it out. The reason the steps are bigger is because our equation was stretched. Stretched by 2. So that means those steps that would take us from point to point on the parabola aren't going to be 1, 3, 5. If it's stretched by 2, it's going to be 2 times bigger. And that's where our new steps come from. So we graph the vertex and then we use our new steps. Our new steps are 2, 6, 10 over, my table got cut off here. So let's fill this in really quickly. Our vertex was 3, 2. Our direction of opening, well, since we're positive, positive people smile. Smile looks like a U and up. The step pattern is usually 1, 3, 5, but our step pattern is 2, 6, 10. And our directions would be over 1 up 2, over 1 up 6, over 1 up 10, and that would get us to the next points on our graph. So let's do that. From our vertex, go over 1 up 2. That gets us to our next point. Over 1 up 1, 2, 3, 4, 5, 6. And we're out of room. We can't get any more on the graph. So back to the vertex, over to the left and up 2. Over 1 more and up 6. And there we have a parabola. This is y equals 2, x minus 3 squared plus 2. And there's the steps. 2, 6. Now we don't have to put those on, but there's the 2 and the 6 of the step pattern. So you can use transformations like we did in the last lesson, or you can use the step pattern. So let's do a couple more of these to make sure that we've got the step pattern down, and then you'll get to decide what method you like better. Do you like using transformations, graphing the original, stretching and then shifting? Or do you like step pattern, graphing the vertex first and then multiplying the steps 1, 3, 5 by whatever A is to get your new steps and then using those steps? Well, let's do a couple and then you'll kind of get to decide. So as I kind of just discussed, our steps for using the step method: identify and plot the vertex first, determine the step pattern. The step pattern would be 1, 3, 5, but if you have an A, something that's not, or something that's stretching or compressing, you would multiply 1, 3, 5 by all those steps. So we do that. Then you graph the step points. So you start at the vertex, and then you can reflect each point across the axis of symmetry to get new points. Now when I showed that on the last page, we just kind of stepped to the left and up, and it's the same thing. And then draw a smooth curve. So we've got two here that I want you to try. I just did one, so what I would suggest is if you want to try one, you can pause the video and try the first example where we're going to multiply all our steps by -3 and start at a vertex of -1 and 6, and you can try that one on your own. I want to do one with a decimal just to make sure we can work with decimals as well. So if you want to, pause the video, try the one on the left. If you want to try it after, that's fine too. We're going to move on with the one on the right. So let's try to follow the steps. First step is to identify and plot the vertex. Our vertex is 3, 2. The key here is remember to take the opposite sign for the vertex. Okay, it says -3 here, so our vertex uses 3. The one you just may have done or are about to do after the video says +1 here, so our vertex will be -1, 6. Direction of opening, A value is positive, so we're going to open up because positive people smile. A is a half, so we're going to take our steps, 1, 3, 5, and we're going to multiply by a half. You can do that in your calculator by multiplying by 0.5, or you can divide all these numbers by 2. If we do that, we get 0.5, 1.5, and 2.5. So how do I graph this? Well, graph the vertex first, 3, 2, and then use the steps. So over 1, up half, put us here. Over 1 more, up 1.5. So there's my half, and there's my 1. And the next step, over 1, up 2.5. 1, 2, and a half. And there's my points on the left. Now we can repeat that process, points on the right. Now we can repeat that process on the left, or we can use the axis of symmetry. We know our graph is going to be symmetrical around the vertex. So if we have a point here, that means we're going to have another point here. If we have a point here, we're going to have another point here. How do I make sure? Count to the vertex and then count across. Count to the axis. 1, 2, 3. So we go 1, 2, 3. And there we have a completed parabola. Connect with a smooth curve. And this is y equals 1/2 x minus 3 squared plus 2. So what we should be able to do from an equation in order to graph these is we need to be able to look at the equation, identify the vertex, the step pattern, and the direction of opening. So let's give it a shot. I have a completed one here. What I would like you to do is to try to pick out the vertex, the step pattern, and the direction of opening of this equation. What I'm going to show you to do is how to go backwards. So you can try this one on your own. We're going to use this one. A vertex, a step pattern, and a direction of opening, and we want to be able to build the equation. So we know we need to fill in something here for A, X, something in the bracket, and something after the bracket. The thing in and outside the bracket come from the vertex. H, K, A. Here's H, there's K. So if H is 20 in the bracket, we should have minus 20. If K is negative 10, the y of the vertex, then outside we should have minus 10. That's pretty straightforward, and that follows exactly with the top example. 2 minus 2. 20 minus 20. 1, 1. Negative 10, negative 10. Follows the pattern. Now our steps, instead of being 1, 3, 5, are negative 1, negative 3, and negative 5. And we're opening down. Down tells us that A is going to be negative. Negative what, though? Well, negative something times 1, 3, 5 gave us our new steps. Well, our new steps are the same numbers, just with minus signs. So that means our A must be minus 1. And you can get that by taking any of these steps and dividing them by whatever the step should have been. If the step should have been 1, 3, 5, take negative 1, divide it by 1, we get negative 1. Take negative 5, divide it by 5, we get negative 1. Either way, we're ending up with negative 1, and that's what we put in for A. There's our H, there's our K. So we can build an equation using the properties from a graph. And that's going to become pretty important when we do 4.4a part 2, which is what I need you to do for your next video lesson. So try those two examples if you haven't already, and that's it for 4.4b, graphing using step pattern. Thanks for watching, and I'll see you next time.